Good evening, and welcome to Story of the Cosmos. Tonight, we travel from the Sun's fierce outer edge to the quiet cold at the far end of our solar system, learning, world by world, what your body would actually feel there. The Sun's outer atmosphere, its corona, burns at over 1 million degrees, hundreds of times hotter than the bright surface below it. And yet the plasma itself could barely warm your skin. It is so thin, so nearly empty of matter, that there is almost nothing there to pass that fire along. Make no mistake, this close to the Sun, the raw sunlight alone would be lethal. But the million-degree heat itself is a different, stranger thing. Heat and temperature, it turns out, are not the same thing. A gas can be scorching by one measure and harmless by another, simply because there are too few particles in it to pass that fire along. From the thin plasma around you, if standing there were possible, you would feel closer to nothing than to flame. This is the strangest fact in the whole of this journey, and perhaps the truest thing it has to teach. Your senses, warmth on skin, weight in your knees, the hush or roar of moving air, were shaped by one particular planet, one particular pressure, one particular pull of gravity. They serve you perfectly here, in this room, in this bed. But carry them anywhere else, and they start to lie. Not maliciously. They simply were never built for the places they are about to describe. Beneath that shimmering million-degree veil, the Sun's visible face itself glows at a comparatively modest 5,500 degrees. Its gravity would press on you with the weight of nearly 2 tons. And flowing outward from it, in every direction, a wind moves at hundreds of kilometers each second, fast enough to seem violent, and yet so sparse, so few particles for every breath of space, that it could never fill a sail or stir a flag. Speed without substance, heat without burning. Even here, at the very center of everything, the universe declines to behave the way your body expects. So tonight, hold that paradox gently as we move outward, past a small, scorched world with ice hiding in its shadows, past clouds of acid that never touch the ground beneath them, out to moons that breathe and comets that bounce, and a heart-shaped glacier quietly weeping in the dark. None of it will feel the way you imagine. That is rather the point. Let the Sun's strange, gentle fire be the first lesson, and let the rest unfold slowly. Nothing out there is quite what it seems. 2 sensations in, and the journey has barely begun. The Sun's fire was strange enough, but its 2 closest neighbors are stranger still, and neither one behaves the way its distance from that fire would suggest. Start with Mercury. It sits nearest the Sun of any planet, and by noon its surface bakes past 400 degrees Celsius, hot enough, almost, to melt certain metals. But Mercury keeps no atmosphere worth the name, only the thinnest exosphere, too sparse to hold or carry heat anywhere at all. So when the Sun sets, it simply leaves. No blanket of air to slow the loss. Temperatures fall to nearly 180 degrees below zero by the depth of night, a swing of over 600 degrees between noon and midnight, the widest of any world in this story. And near its poles, inside craters where sunlight has never once reached the floor, the cold runs deep enough and old enough that scientists believe there is ice down there. Water, frozen since before memory, hiding in permanent shadow on the planet closest to a star. Venus is Mercury's opposite in almost every way, and yet somehow crueler. Descend through its clouds, pale, sulphurous and high, 60 or so kilometers up, and you'd expect the acid there to be the danger. It isn't. Nothing acidic ever reaches the ground. What waits at the surface is simpler and worse. Heat alone, dry and relentless, hot enough to melt lead, under a crush of air 90 times heavier than Earth's, roughly what you'd feel a kilometer deep in one of Earth's oceans. And because that atmosphere is so thick, it holds its heat like a closed room. The temperature barely moves between day and night. There is no dusk on Venus, in any sense your body would recognize. Only the same furnace, always. And the strangest part isn't the heat at all. It's the wind, or what little there is of it. Down at the surface, Venus's winds creep along at something close to walking pace, less than an arm's length per second. Yet the air is so dense, so heavy, that even that faint breath carries enough force to drag sand across the ground and streak the dust into long, visible trails, seen from orbit by spacecraft radar. A wind too gentle to raise the hairs on your arm on Earth, here, has the strength to move a landscape. In March of 1982, a Soviet lander named Venera 13 dropped through that crushing air and reached the surface intact, one of the very few machines ever to do so. And it returned data from that furnace for a little over 2 hours. In that borrowed time, it carried a microphone and switched it on. What came back was not static, not noise stripped of meaning. It was wind. Real wind, recorded on the ground of another world for the first time in human history. Faint, steady, and strange, the sound of a place that looks like hell, and in that one recording, simply sounds like weather. Two worlds so close to the sun and so close to each other, one that cannot hold its heat at all, one that cannot let it go. Neither one forgiving. The corona's fury has no partner here. Step off from the twin extremes of Mercury and Venus, and the next world down feels almost gentle by comparison, until it isn't. 1/6 of Earth's gravity means every step becomes a slow-motion bound, a place where a 70-kilogram body suddenly weighs less than a bag of soil, 12 kilos, no more. Walking here would feel less like walking and more like drifting, deliberately, each footfall taking a beat too long to land. But the moon keeps no atmosphere to soften anything. At full noon, the ground bakes past 120 degrees Celsius. By nightfall, the same spot cools to nearly minus 130. And in certain craters near the poles, places where sunlight has not reached in billions of years, the temperature falls even further, past minus 240 degrees, among the coldest anywhere ever measured. No wind carries that cold to you, and no wind carries the heat away. Only direct light and its total absence. And yet, for all that violence of temperature, what the 12 people who ever stood there remembered most vividly wasn't the cold, or the heat, or the strange low bound of their own footsteps. It was a smell. Lunar dust clings to everything: boots, gloves, the ridges of a spacesuit, and Apollo astronauts who carried it back into their sealed, breathable cabins kept noticing the same thing the moment their helmets came off. That fine grey powder, dormant for eons, untouched by oxygen since the moon itself was born, met breathable air for the first time in the crew cabin, and it smelled like spent gunpowder. Sharp, faintly metallic, unmistakable to more than one veteran who had actually smelled gunpowder before. It is a strange thing to carry home from another world. Not a sight, not a sound, but a scent. A world with no air of its own, borrowing, just once, a smell we already knew. Overhead, still, hangs the blue marble those same astronauts had left behind, close enough to blot out with a thumb, far enough to feel, for the first time in human history, like something small. Our nearest neighbor, and still nothing like home. And so it rests. The moon still hangs there in memory as we drop toward Mars, where standing on the equator at noon feels like two seasons occupying one body at once. Spring at your feet, winter at your head. The ground beneath a boot print can reach a mild 24 degrees Celsius, almost gentle, almost familiar. But raise your head to where a person's face would be, and the air is already freezing. Mars's atmosphere is too thin, barely 1/100th the thickness of Earth's, almost entirely carbon dioxide, to do what Earth's air does without thinking. Carry warmth upward, blend it, even it out. Here there is nothing to blend it. Heat simply stays pinned to the ground that made it, and the column of air just above dips into winter before your knees have finished feeling spring. That same thin air does something else nowhere else in this journey does. It splits sound itself into two separate speeds. Low, deep tones drift along at about 240 meters each second, and higher tones, oddly, outrun them, arriving nearer 250. On Earth, every pitch keeps pace with every other, a single wall of sound moving as one. On Mars, given enough distance, a sharp sound would slowly come apart in the air, its highs reaching you a breath before its lows, an entire planet, quietly out of tune with itself. For years, that thinness made Mars sound like the quietest place a working microphone could point. When Perseverance's instrument first opened its ears on the Martian surface, the silence was so complete that engineers wondered, briefly, if it had simply broken. Then, one afternoon in September, it caught something. Not a voice, not wind in any familiar sense. 308 individual grains of dust, ticking against the rover's own body, one by one, as a dust devil swept past. A spinning column of air, some 25 meters wide and taller than a 100-meter building, had wandered within earshot, and for the first time, a storm on another world had been heard rather than only seen. Above that quiet drama, the sky itself runs backward from what your eyes would expect. By day, it wears a dusty, butterscotch tan, iron-rich grains suspended too high to settle. But watch the horizon at sunrise or sunset, and the color inverts. A haze of blue creeping in exactly where Earth would turn its deepest orange, the one moment each day when Mars borrows a color that belongs, on Earth, to midday. It is worth pausing, too, on what Mars is not. Its gravity holds you at just over 1/3 of your Earth weight, light enough to make walking feel like something closer to bounding. But that same thin air means none of it presses on your skin the way a true winter would. There is no wind-chill bite, no gust to lean into. The cold at your head is real, measurable, but it arrives without pressure, without a voice of its own. Just a stillness that happens to be freezing, wrapped around a ground that is, only inches below, still holding on to spring. A world split down the middle by its own thin air. A raindrop-shaped chunk of rock drifting between Mars and Jupiter typically has nothing but empty space around it, further than the eye could ever see. Picture the asteroid belt the way old films show it, hulls weaving between tumbling boulders, collision a constant threat. That image is almost entirely wrong. Every spacecraft that has ever crossed the belt, from the Pioneers to Voyager to Juno, has done so without ever once needing to swerve around anything. The belt is not a field of obstacles. It is mostly nothing, with occasional rock. Ceres, its largest resident, sits alone out there in the cold, daytime highs reaching up toward 240 Kelvin, with only the faintest, most fleeting atmosphere, breathed out in wisps as its own water ice slowly turns to vapor and drifts away. Push further out, past the belt entirely, to a smaller and stranger kind of world, a comet. In November of 2014, after 10 years chasing it across the solar system, the European Space Agency's Rosetta mission released a small lander named Philae to toward the surface of Comet 67P. The comet's gravity is almost not gravity at all, about 5 millionths of what you feel standing here. So faint that engineers calculated a person walking briskly in the direction of its spin could simply keep going and never come back down. Philae touched down at a gentle walking pace, barely faster than a stroll. And because there was so little to hold it in place, that soft landing became a bounce. Not a jolt, not a crash, a slow-motion float, off the surface and back into the dark, then off again. For almost 2 hours, the little lander drifted across the comet's landscape before gravity, such as it was, finally, patiently, drew it down to stay, nearly a kilometer from where it first touched. If you had been standing there yourself, weightless in that same bounce, the comet would not have been silent in the way deep space usually is. Not quite. Instruments aboard Rosetta sampled the thin haze of gas leaking from 67P's surface as sunlight warmed it, and found water, carbon dioxide, and carbon monoxide making up the bulk of it, laced with faint traces of things that would smell if there were enough of them to smell. A whiff of rotten eggs, a hint of ammonia. But the comet's entire atmosphere, spread across that vast bouncing arc, was too thin, too diffuse, for any human nose to catch even a trace of it. A chemically real perfume, worn by a world with nothing to carry the scent. This is a place built almost entirely of absence, of asteroids that mostly aren't there, and a comet so light it can barely keep hold of what lands on it. A shipwreck lifted into the sky, made of gas and lightning. Jupiter takes the storm and simply makes it larger than a planet. Winds along its equator tear past at over 300 miles an hour, and inside the pale eye of the Great Red Spot, they climb past 400. A storm that has now outlasted centuries of human watching. Above the poles, lightning gathers in bursts of 4 strikes a second, as fierce as the strongest thunderstorm on Earth, but circling a world with no ground for the bolts to reach. In 1995, something did reach that ground, or as close to ground as Jupiter has. A small probe from the Galileo spacecraft fell into the clouds at over 170,000 kilometers an hour, slowing so violently that it briefly glowed hotter than the surface of the Sun itself. For 58 minutes, it kept transmitting as it sank nearly 200 kilometers deeper, the pressure around it climbing to 23 times what you would feel at sea level on Earth, until the crushing atmosphere finally silenced it. No spacecraft has gone deeper into a giant planet since. Out at the edge of that same system of moons, a smaller and stranger rhythm plays out, not once, but every few days. Io, Jupiter's innermost large moon, is the most volcanically restless body known, its vents spitting lava hot enough to outshine anything on Earth, even while the moon's own surface sits at a bitter -130 degrees Celsius. Thin as it is, Io still holds a fragile atmosphere of sulfur dioxide, only barely clinging to the surface. And once in every orbit, once every Io day, the moon slides into Jupiter's enormous shadow, cut off from the Sun entirely. What happens next is close to breathing. Within minutes of losing the light, most of Io's thin atmosphere begins to freeze, gas turning to frost across the moon in one continuous exhale run in reverse. It stays that way in the dark, a moon wrapped in its own frozen air, and then sunlight returns. Within about 10 minutes, the frost lifts back off the ground and turns to gas again, and Io has its atmosphere back until the next shadow comes. No wind carries this cycle, no weather system drives it, only the plain fact of light and its absence, timed to an orbit, over and over, as steady as a held breath. Jupiter's other large moons keep their own separate weather of danger rather than temperature. Europa, sheathed in ice, sits under radiation fierce enough to threaten an unprotected person within hours, though that danger is not evenly spread. It bites deepest near the equator and eases sharply toward the poles. Ganymede, the largest moon in the solar system, generates a magnetic field entirely its own, wrapping itself in private auroras that flicker in time with the vast magnetic field of Jupiter around it. And Callisto, the most heavily cratered of Jupiter's moons, drifts largely outside the worst of that radiation altogether, a quiet moon at the edge of a violent neighborhood. Everywhere on this giant and its court, scale simply keeps replacing familiar limits. Wind becomes hurricane, hurricane becomes something with no end and no coastline. An entire moon learns to hold its breath. Corona's over. Wind becomes hurricane, hurricane becomes hexagon. Saturn's upper winds run past 1,800 kilometers an hour, a scale of motion with no real analogue in a human life, and at its north pole, that motion resolves, strangely, into order. A hexagon of jet stream, 6 straightish sides wrapping the pole, spanning some 30,000 kilometers, room enough inside its borders for roughly 4 Earths. It was already old when Cassini finally photographed it clearly, decades of storm, holding the same 6 corners the whole time. Not a single storm circling, but a shape the atmosphere itself seems to prefer. Titan is calmer. Its air is thick, 4 times denser than the air around you now, and the pressure at its surface is only some 60% higher than sea level here. Combine that dense air with gravity barely 1/7 of Earth's, and the two effects nearly cancel the danger out of falling. A person wearing wings strapped to their arms could, in principle, beat them and rise, actually fly under nothing but their own strength. It sounds like fantasy. It's simple physics, thick air and weak gravity meeting in one place, and it's serious enough that a real spacecraft, a rotorcraft named Dragonfly, is being sent to fly there for real within the next decade. Rivers and rain fall on Titan too, the only other place in this whole journey with liquid pooling on its surface, though what fills those rivers is not water, but liquid methane and ethane, cold enough to stay liquid at nearly 180 degrees below freezing. Saturn keeps one more quiet thing worth knowing. At the south pole of the small moon Enceladus, cracks in the ice vent plumes of water vapor and ice grains out into space at some 400 meters a second. Almost all of that spray, more than 95%, simply falls back down as fine snow, coating Enceladus in ice so bright it reflects nearly all the sunlight that reaches it, making this small moon the most reflective object anywhere in the solar system. The rest escapes entirely, drifting out to feed one of Saturn's rings. But the plumes are only the visible edge of something larger. Beneath that bright ice sits an ocean, liquid, salted, kept from freezing by warmth rising through vents on its own seafloor, vents Cassini never touched, but whose fingerprints it caught. Tiny grains of silica that only form where water meets rock at 90 degrees or more. Hydrothermal warmth, real and recent, inside a moon that from orbit looks like nothing but a small ball of ice. Cassini spent 13 years learning this, and when its mission finally ended, in September of 2017, its handlers did not let it drift. They aimed it, deliberately, into Saturn's own atmosphere, and let the planet's storms tear it apart. A spacecraft sacrificed on purpose, so that it could never someday fall, uncontrolled, onto the ocean it had just spent over a decade proving was there. It kept transmitting data the entire way down, until the pull of the atmosphere finally turned its antenna from the Earth. A world guarded by the very probe that found it. The coldest air ever recorded anywhere in this solar system was not found on the planet farthest from the Sun. It was found on the one tipped over on its side. Uranus's atmosphere has dropped to 49 kelvins, nearly 224 degrees below zero, the coldest atmosphere ever measured in the solar system, colder even than anything recorded on Neptune, half again as far from the Sun. It seems backward, since Uranus sits closer to the Sun and should, in theory, hold a little more warmth. But Neptune leaks far more of its own inner warmth than Uranus does, leftover heat still radiating up from its interior, gently topping up what little sunlight brings so far out. Uranus gives off only a whisper of inner heat by comparison, and why two such similar neighbours should differ so sharply is a question no one has fully answered. And then there is the tilt itself. 98 degrees, the most extreme lean of any planet, so severe that Uranus does not so much spin like the other worlds as roll along its orbit like a dropped ball. For roughly 40 years at a stretch, one pole points directly at the Sun, while the other sits in total, unbroken darkness. An entire hemisphere waiting out decades of night before its slow turn toward morning. Neptune, despite being colder in its deep interior sense of distance from the Sun, cannot claim that record. Its own heat keeps its air a little less brutal. What Neptune keeps instead is speed. When Voyager 2 passed by in 1989, it clocked winds tearing frozen methane clouds across the planet at over 2,000 kilometers an hour. The fastest winds ever directly measured on any planet in this solar system, faster even than Saturn's already tremendous 1800. It is worth pausing on that comparison, because Saturn's winds are the ones best known, watched for over a decade by a spacecraft that orbited it again and again. Neptune's record comes from a single flyby, one brief pass with one set of instruments, gone in an afternoon. The fastest winds we know of were caught almost by accident on a spacecraft that would never come back to check if they had slowed. Out past Neptune, past even the icy debris that scatters starlight in every direction, sits Pluto. Small, distant, and by any ordinary measure, dim. Sunlight reaching its surface is only about 1/900th as strong as it is here on Earth. And yet, stand there at what passes for noon, and NASA describes the light as roughly what you would find in a well-lit room indoors. Brighter, in fact, than a full moon over Earth on a clear night. Enough to read by, comfortably, on a world so far from its star that the Sun itself would look like little more than an unusually brilliant point of light among all the others. Above that thin, cold ground, Pluto keeps one more quiet trick borrowed from home. Its high, hazy atmosphere scatters blue light through the very same process that colors Earth's sky, even as the same fine particles responsible for that haze slowly drift down and settle across the surface, painting it in shades of rust and reddish-brown. A blue sky, seen from a world with barely any air at all, 100,000 times thinner than Earth's, over ground colored by the sky's own leftovers. And on that ground, near Pluto's equator, lies a glacier larger than Texas and Oklahoma combined, shaped, by nothing but coincidence, like a heart. Sputnik Planitia was one of the enduring images New Horizons sent home when it passed Pluto in 2015. A vast plain of frozen nitrogen ice that scientists assumed for years afterward was simply that. Frozen, settled, essentially finished. Then, in 2026, a new look back through that same decade-old set of images found something nobody had noticed the first time. At the glacier's edges, cracks show signs that liquid nitrogen has reached the surface surprisingly recently. Not ice, not vapor, but liquid, wetting the ground in passing across a world with an average temperature of nearly 232 degrees below zero, where the air itself presses down with barely 100,000th of Earth's atmosphere, and where a person would weigh only a fraction of what they weigh here, drifting almost as much as walking. Pluto was supposed to be a still photograph, a world done changing eons ago. Instead, an old picture, looked at more carefully, showed a world that had wept, and recently. Even out at the edge of everything, nothing has finished happening yet. And so it rests. And the last sensation is this. The pillow under your head, right now, is doing something no other surface in this entire tour could do. Every world you've just crossed made your body work to survive it, pressing back against your skin, or pulling too hard, or offering nothing to breathe at all. Earth doesn't work at anything. It simply happens to match you. The air pressing against your face carries exactly enough oxygen at exactly enough pressure for your lungs to take it in without a single thought. Gravity holds you to the mattress at the one strength your inner ear, your bones, your blood ever learned to expect. Not the crushing weight of the sun's surface, not the drifting looseness of the moon, just the ordinary pull that lets a body rest instead of fight. Sound moves freely through this room, air molecules close enough together to carry your own breathing back to your ears, something most of the solar system cannot offer at all. None of this took engineering. It is simply where you already are. It is worth remembering, gently, what was actually true and what only sounded true along the way. The sun's crown is fierce in temperature and almost nothing in substance. Mercury is not the solar system's hottest address once night falls. Venus's famous acid never touches its ground. The asteroid belt was never the crowded field the films suggested. And even Pluto, at the very edge of the journey, turned out not to be finished. A heart-shaped glacier that wept liquid nitrogen surprisingly recently, 4.5 billion years in. Wonder, it turns out, survives contact with the facts. It just changes shape. So let the night's sensations settle now, one after another, like snow after a long storm. The corona's paradox, the Venusian hush, the Martian dust devil's soft ticking, the comet's 2-hour bounce, a moon's breathing in and out with an eclipse, wings that could work in Titan's thick, sweet air, an ocean world that gave its life to protect what it had found, a glacier that wept, just recently, at the edge of the dark. None of them were built for you. Only one world was ever that. You can stop imagining now. This is where you already belong. This has been a story of the cosmos. Out there, the stories go on, slowly, quietly, as they always have. Let this one drift on without you, until the next journey.